let's take a look at a little recap of the things we learned while we studied Chapter 2. Okay, a lot of what we did was graphing equations, okay, with the transformations and the growth charts. So the first thing that I notice here is this equation is not ready because the x is not alone. Okay, so we're going to have to go ahead and get it ready. Okay, so what that means is you get the x alone. F of x is equal to, so this negative is going to stay outside, and the 2 is going to stay inside. But what I'm going to have to do is use double parentheses, okay, because I want the 2 inside still getting cubed. That's going to be x minus, and that's going to be a 1, okay, minus 4. So this is in ready form. Now let's go ahead and state our transformations. This negative right here means you're going to reflect over the x-axis. Okay, out in front is x-axis. This number inside here, that is a horizontal. Is that stretch or shrink? It's weird. It says 2, but it means shrink, and you're going to shrink in half. Weirdo. Everything inside is weird. This minus 1 tells us to shift to the right 1. Okay, everything inside is weird. The outside stuff is just like you'd expect. This is vertical, and that's going to be a shift 4 units down. Okay, so a regular x cubed, let's just remind everybody, okay, goes up, up, up to the right. But a negative x cubed is going to be going down, down, down to the right. Okay, so we're going to have to make sure that we draw our graph with this kind of shape. The other thing we should make note of is the growth chart. So how did, over and up, how did a regular cubic grow? Over 1 up, 1. Over 1 up, 7. Over 1 up, 19. Okay, that's as big as we're probably going to need. So we're going to have to go ahead and adjust these because we have a horizontal shrink in half. Which ones are the horizontal ones? The overs. Okay, so all of these overs are just going to be 1/2. Okay, I think we have everything we need to go ahead and do this. Okay, so we're going to take our center point. We're going to go 1 unit to the right. We're going to go 4 units down. Okay, so there's our center point. I've got that. I did that. I got the shrink. Okay, reflect x-axis. I'm going to go down, down to the right. And my shrinking is on the chart. Over 1/2, down 1. Over 1/2, up 1. Okay, the next one is over 1/2, down 7. Okay, there's no way I'm going to fit that on the graph paper. Let's check and see if I can fit 7 up here. Over 1/2 takes me to the y-axis, and then up 7. 1, 2, 3, 4, 5, 6, 7. I am at the point 0, 4. 0, 4. Okay, is there any way to check to see if that is the correct point? Okay, you can take this and plug this point back into the original equation and see if you got it right. 2 times 0 minus 2 is negative 2 cubed is negative 8. That turns into a positive 8 minus 4. It works. Okay, always plug it into the original equation to see if you got it right. Okay, make sure you look at the growth charts for parabola, absolute value, and the square root. Okay, something else from Chapter 2 is the difference quotient. Okay, does anybody remember what the difference quotient was? The difference quotient. Okay, it was a huge fraction. And what goes first? F of something big. It was x plus h. Okay, then just minus your f of x, and all that gets divided by h. Okay, so there's the difference quotient formula. I remember when we taught this, we kind of separated our paper in half because it was a rather complex calculation. Okay, so over here on the left, we always did the f of x plus h first. So we're just going to take our function and plug in that quantity. Especially when it was something squared, this took a couple of steps over here, and I don't want to get my difference quotient complicated. So my input is the quantity x plus h. And he says 5 times input. 5 times input minus 3. 5 times input minus 3. Okay, and the input is x plus h. We'll go ahead and distribute that. 5x plus 5h minus 3. Okay, and for people that are using equal signs here or labeling, this is not f of x. That's f of x. This is not difference quotient. This is f of x plus h. Okay, now the good news is when you're taking your final, I'm not going to be looking at your work a whole lot, am I? All right, now on this side of the paper, I'm going to be looking at difference quotient. So now you draw that big long bar with the h. Okay, so the first thing is whatever you got over here for your f of x plus h, that needs to go first. And then you have to minus your f of x. You have to minus your f of x. You have to minus, change. Minus 5x, and then you have to add a 3. Okay. Now remember what happens if you're doing things right. Lots of things will cancel here. Okay, after you cancel, you go ahead and write what's left. 5h divided by h. Okay, and the difference quotient is just simply a 5. Difference quotient is 5. Okay, do you remember a trick when you were doing this? If your function started off as a linear, okay, this answer right here is just the slope. If your function was linear, the change is the slope. But if it's not linear and it's going up and down, then it's going to have some letters in it. Okay, cool. Let's take a look at domain. Let's take a look at domain, the rules for domain. Okay, so there's 3 domain cases. The first case here, okay, if you're under a radical, okay, x minus 5, you take that expression, and it has to be greater than or equal to 0. Good. Okay, so this one you would just simply add the 5, and you would be more than or equal to a 5. Okay. How about an expression in the denominator? Okay, you write down the expression. Since you're in the denominator, you cannot equal 0. This one's weird. Can I do this? Of course, after last chapter, this should be easy, right? When you have a equal sign, you can simply move things over and you can square it. So x cannot be plus or minus radical 7. Don't forget about the plus minus. Okay, there's 2 answers there. Sometimes there are multiple cases. Okay, I'm noticing here that I have a numerator, but there's nothing wrong with absolute values. Okay, here there's an expression in a radical in the denominator. So that's going to get a little weird. Okay, if you are in the denominator, you cannot equal 0. But since you're in a radical, you also have to stay positive. So this is a combination of the first 2 cases, just greater than 0. Okay, and so here x would be greater than negative 11. Okay, and those are the 3 domain rules. Okay, what else did we do in chapter 2? Okay, we learned how to find an inverse. Okay, finding an inverse, let's just go ahead and write down those steps for people. Okay, how to find an inverse. Step 1 was you switch x with y. You switch x with y. So this is y equals, so I'm going to write x equals, and then that's going to be 2y minus 1. Y plus 3. Okay, then you go ahead and you solve for the new y. So you want to make it be y equals. So I'm going to go ahead and cross multiply here. 2y minus 1 equals xy plus 3x. Okay, I'm trying to solve for y. Oh my goodness, and I noticed that there's y's all over the place. There's y's on the left and the right, and I don't like that. I'm going to put them all on one side. I'm just going to pick the left side. So minus xy is going to go on the left, and then I'm going to add 1 and put that on the right. Okay, well at least they're on one side. Now how do I get them together? Come on, what's the answer to everything in my class when you guys get stuck? You factor. We're going to factor out the y. Well, how is that going to get them together? Oh, I see. Now it's just 1y. And then that would leave us with a 2 minus x. Okay, that's great. But how does that make it be y equals? How is the y going to get alone? How do I get this expression out of there? You divide by it. Divide by it. Gone, gone. Okay? And so I've got an answer of 1 plus 3x over 2 minus x. And what does that equal? Nope, we're not going to say y. We're not going to say y because the third step was use inverse notation. Use inverse notation. What does that mean? I can't call it y or f of x. Let's use a red pen. You're going to call it f inverse of x. Now, lucky for you, when you take your multiple choice test, you'll see those answers and you're going to pick the right one. Okay, so we talked about easy domains. Let's talk about domains here. Domain of composed. Composed. This is where it got a little hard for some people. Okay, I like to write this as f of g of x. Okay, and so the domain of a composed was a two-step process. Step 1, you find the domain, okay, of, quotes, the little guy, whatever the little function is. Okay, and then step 2 was the little function must obey the big function. Okay, so let's go work on our steps over here. Step 1, the domain of the little guy, which happens to be g. So what's the domain of this? The expression under the radical has to be greater than or equal to 0. Okay, so g wants numbers that are more than or equal to -7. Okay, now step 2, let's just put a star by this one because this is the one that required some work. The little one must obey the big one. The little one is g going into f. So let's write down the g expression, the whole function here, the radical and everything. The g function must obey f. Does f have any restrictions? F says do not equal 11. Okay, now how do you solve something like that? Since it's an equal sign, you're allowed to do more things. You're going to square both sides, both complete sides, big parentheses. Okay, so luckily here the entire quantity square rooted just cancels out. That's going to be 121. Okay, and then when you subtract 7 from both sides, x cannot equal 114. Okay, then you're going to put both of these together. So the domain is, oh, but let's not be redundant, right? Okay, so he says use numbers more than or equal to -7. Do I have to say, and don't use 114? Yes, you have to include that, and x's cannot equal 114. Okay, overall domain for the composed. You have to do the two-step process. Okay, let's try that again, only because this is the most fun kind of domain. Okay, f of g of x. Okay, so g is the little guy again. Okay, so step 1. The little guy says x minus 1 cannot equal 0, so x cannot be a 1. Now step 2, g of x has to obey f. Let's write down this g function, the whole thing. Okay, the whole g, so g of x is right here. Okay, has to obey f. And the rule for f here, let's see, what does his rule say? Be more than or equal to 0. So he wants to be more than or equal to a -2. So the g function has to be greater than or equal to -2. Okay, how are we going to solve this? Can I multiply both sides by a quantity? No, Now, how do you solve an inequality when it's a fraction? This was from chapter 4, actually. We're going to move everything over to one side. Okay, so let's go and add the 2. And how do you add fractions? The answer is common denominator. We're going to multiply the top and the bottom by the denominator of x minus 1. Okay, so now we have common denominators. I have the 0. This is going to be 2x minus 2 plus 4 plus 2. Okay, so how do you solve something like this? You got to use a number line. And there's 2 critical values. One of the values is going to be a positive 1. And what's the critical value from this guy? If you're not sure, you could always crawl in the corner, say equals to 0, and you can solve this manually. X is equal to negative 1. Okay, so the 2 critical values are plus and minus 1. Let's talk about the bubbles. Is the bubble at 1 going to be open or closed? The answer is open because it comes from the denominator. How about negative 1? It came from the numerator, so it's going to be closed because of that sign. Okay. Then we're going to go ahead and test the sections. Let's try 0 first. Let's test x equals 0. 0 plus 2 is 2, divided by negative 1. Is that answer positive? Nope. Nope. Okay, let's try, do you guys like to try big numbers or small numbers, like 10? 20 plus 2, that's positive. 10 minus 1 is positive. A positive divided by yep, that's going to work. Okay, so here's a good section. How about over here? Let's try negative 10. Negative 10. Negative 20 plus 2 is negative. Negative 10 minus some more is negative, and a negative divided by negative, that's going to work. Okay, so what's the overall domain? From negative infinity to negative 1, and then parentheses 1 to infinity. Okay, there's the overall domain. Oh, what about this guy? We have to include him. Do not use 1. Oh, don't worry, I'm not using 1. I put an open parenthesis on him. Okay, and that's a recap of chapter 2.